And welcome back to another MATLAB tutorial. In this edition, I will be showing you how to graph. Now in MATLAB, you're going to be doing a lot of data analysis, so sometimes it may be easier just to graph in MATLAB rather than moving this data over into Excel. That can get tedious, so I'm going to show you how to keep it in MATLAB and how to plot your figures and whatever else you need. So for starters, you're going to need just a debriefing. For this, if you notice the layout of my previous videos, most of them I'll go over each topic and then do a little example on it. But for this one, it doesn't really make sense to do an example of each definition. They all kind of coincide with one another, so it's kind of like a sandwich. Like I don't want to show off just the bun of a sandwich. You know, you need the bun, you need the meat, you need the vegetables, the condiments, all that. So I'm going to go over each one briefly and give a little bit of background just so you know what it does. And then at the end, I'm going to show you all how it all coincides and fits together to create a figure for this example. So, alright, let's jump into it. To begin, we have the figure command. The figure command is just to show that you want a figure window. As you can see, this is our MATLAB window, and so we want a figure window to pop up so that we just see our figure, and that'll be helpful to us just to analyze our data. But I'll show you more of what this does and what you can do within the figure command to title it and things like other ways to title it as well. So there's a couple things that you can do, and so that is the figure command. Next up, we have the plot command. And so the plot command is basically just used to plot your data. So while it denotes, we have X, Y in here, you can do X and Y would just be what you want to plot next to each other. So data 1, you can plot data 2. Now, as we can see, when you type in a plot command, there's a bunch of other things that you can show. I've showed you how to use the help command. The help command really goes into detail about what the differences are between all of these different plots. So you can check that out. For this example, I'm just going to be doing data 1, 2, really. That third variable is kind of like what kind of lining you want, things like that. You see, if it's not specified, it'll just go to default, so that's not always a bad thing, but sometimes for different plots you might want like a dotted line or just points, so you can mess around with that. Now our axis, you can specify this. Now you don't have to. Usually, sometimes it works better with different ranges of data, like if you just care about a specific point or area, I guess. That's when you would want to break it down rather than seeing the full picture. But again, this is optional, and MATLAB will default to axes by your given data range. So that's just another thing you can do. You can add a title using this command, using the title command. And that'll just, it's self-explanatory, kind of just adds a title. And you got to keep the quotes. You got to have the single quotes around it. Just like in this one, you got to have the brackets around it. I didn't specify that, but you need the brackets around this to make it work. You need the quotes around this one to work. And then again, X label provides an X label. You need the quotes. Y label provides a Y label. You need the quotes. Grid on adds grid lines. And grid off removes grid lines. Realistically, you're probably just going to delete the grid on, but there's certain applications where you would use grid off. Alright. Now, for this example, I found a nice little, won't say a solution, but I found a nice little example for this. So I'll give you a couple seconds to read the prompt. I can try and copy and paste this in, but we'll be reading along with it. So I'll just be going through it. We see we have a y sub t function and an x sub t function. We can assume that we're probably going to be graphing x and y over t. So we'll do multiple. This one will actually have multiple plots. think we can even see, yeah, there we go. So just a little spoiler, there you go, little sneak peek. So we're actually going to define some of these variables and then graph our function. So first we read that y of t is the vertical distance and x of t is the horizontal distance traveled by our projectile. So that means we've got a projectile that displaces over an x and also a y, so vertical, and x is our horizontal. G is the acceleration, so we can start putting in some variables. So we know that g equals 9.8, and that's in meters per second. All right, and t is our time in seconds. Now we can look a little ahead and see that t is defined as 0 colon 0.1 colon 10. Now let me just explain that to you. So type that out first. And basically this means, so let me make a comment. So t is our time. This will be our t0, so that's our starting point, by a colon, and then we have our step size, so this will increment by 0.1, and it goes all the way up to tf. So this example, they don't really tell you that, but that is how you define that. This is if you want to increment by 0.1. Now I could also say I can't just say 0 to 10 because it won't know what to, let me see, let me run this, I'll show you. So I can say 0 to 10 and it'll automatically just go by 1, it's a default, but if we do 0.1, then we can see that it now reads it by 0.1. And it'll show you in this scenario. So as you can see, like I said in the previous videos, everything's saved as a matrix. So it's going to tell you this in columns. So right now we have t is a 1 by, so 1 row. So t is a 1 row and it has 101 columns. So we can actually use the command from before to show the 101st element in row 1, which we can see is 10. And we can also see the first row, first column, which will be 0. So that's our T0 and our TF. Alright, so we have our gravity, we have time. It says y sub 0 is 0 and x sub 0 is 0. I'll put it in so you can see it, but realistically you probably don't need to use this. Also, I'm going to suppress some of these now that I've used them so they don't keep popping up every time. And then y sub 0 equals 0. Alright, so we've got some of our function. Alright, we also need the initial velocity, which is 50.75 meters per second. So we will say v sub 0 equals 50.75. And we also need our angle theta, or our initial angle, or projectile's launching angle, excuse me. And that is denoted as 5 pi over 12. So we're getting into some other just simple things with MATLAB. So sine and cosine are always read in radians. If you try doing it in degrees, it won't like that. So always present angles in terms of radians. And also pi is just pi, so where it's a little different from Excel. So 5 pi over 12 would be, you don't really need the parentheses just because over operations, but to make it look how it is, there we go, 5 pi over 12. Alright, and then seems like we have everything, so we can start graphing, or we can start plugging these values into our equation. y equals y sub 0, y sub 0 minus 1/2, 0.5 times g times t squared. Then plus, let me move this a little bit over so I can see it. Then in parentheses, v sub 0 times, it's just sine of theta. We want that all times t. So that's our y value. Now x is going to be, just know it's x sub 0. Then we have, move this over. Then we have plus v sub 0 times cosine of our theta times t. Alright, so now we have all of that done. So we are going to now graph it. So we'll do figure, I'll show you some extra stuff. We'll say figure 1 is equal to, we want to plot, so first is x, we want our time to be on the x, and we'll actually have x on the y for this first plot. What else do we want to show off? We can put in the title. So single quotes, actually double quotes also work, but we'll just keep single quotes for consistency. X of t versus t sub t. Is that how they say it? Yeah. Oh, I guess they just say t. It wouldn't be t sub t. The long day. So we now have x of t versus t in one plot. And oh, yes, our labels. So y label, we actually want, so our y label is going to be horizontal, because it's x, so it's our horizontal distance traveled, and that is in terms of meters. So that's how you do a y label, and then x label is just the same, but this time it's going to be our time in seconds. Alright, and yeah, we'll throw a grid on there. We'll do grid on. And then we can also provide another grid, or another figure, sorry. Let's call this one figure 2. We can take this data, because the only thing, command copy, paste it. Get rid of that. And so for this, we want to say y. This is just the same, it's just y, and now this is the vertical distance. Alright, and I think I want to just finally make sure, yeah, we're ready to plot. So what we do is we would hit our run, and we'll see our figures. Alright, we have an error. Let me see, 42. Oh, I didn't. There we go. Okay, that means I also have to do it here. So you gotta be consistent on those quotes, or it's not gonna work. Wish I did that on purpose to show you, but no, it's just a mistake. Oh, another thing. All right, let's see. Okay, yeah, I have to do it to. I should watch my other videos because there's you gotta use the dot before. Okay, let me see. Again, I should probably watch the other videos. See, this stuff is just practice. You'll learn it with practice. There we go. And then we should be getting our figures. So we have figure 2, which is our y sub t versus t, and we have our figure 1, it's x sub t over t. You see, we called it figure 1, and it shows up here, and figure 2 will show up here. And this is our horizontal distance traveled in terms of meters over time. And we have our vertical distance over time. So we can see that our projectile moved around 130 meters in the horizontal distance, and it varies in vertical distance, hitting a maximum around like 120, 122. So you can then, that's another thing with your plots. The grid helps to see really where things are, and you can also use your cursor along them to see maximum and minimum, so that's kind of helpful. Sometimes it's easier to go in and mess with actually code and find a maximum instead of trying to find a maximum. Let me see if I can show that off. We can also, again, this is probably a lot, but we can use our workspace to see, and then in here I'll do this stuff is like data analysis, so I'll put this in another video, but we can go and check out some stuff in there. And so basically that's just how to graph, run it, get your figures. One more thing I will show is that we can do, if you're doing something like this, this might take a little bit of, let me see if I can do this. This might take a couple tries. Do a subplot, figure 1, subplot. Now this might not go off. Yeah, that's what I was thinking. Let me see if this, oh. Okay. Let me get rid of this figure 1. Let me see if this works. No. Alright, disregard this. I'll look into it and I'll put it in another video. But another thing that you can look in is doing subplots if you have two sets of data like this. Actually, you'll get to see all the troubleshooting. I hope that's not an issue, but I will try and figure out how to do a subplot. Okay. Okay. So let me try that again. Alright, then let me change this to figure 1. Still doesn't like that. Alright. Let me get rid of figure. See if it likes that. No. Hmm. Let me see if it's the... This is honestly a lot that goes into MATLAB, just trial and error. So, okay, like that. So let me add figure 1 above this. This is a little bit of troubleshooting, and this is actually what happens with MATLAB. So close. Let me see if I can do 2. 1, 2. Oh, we're so close. There we go. Okay. That's a subplot. Hey, congrats. Alright, so we can see if we have two sets of data like this, a subplot is probably the better one that we want to go with. 2, I would assume that's the number of position in the middle, and then we have this one as 2, which means it's on the bottom, and 1 would be on the top. There's more that you can go in. Obviously, I'm not an expert, as you can see from some of the trial and error here, but that is how you do a subplot. A lot of the times it'll be beneficial to go into the help menu and to check that out. And yeah, I think that's all that I wanted to cover as far as graphing goes. just with a little of some extra stuff I knew, just to help you guys out. So hopefully it wasn't too confusing, but did my best, and hopefully it helps you guys out. Thank you.